Welcome to the Real Python Podcast. This is episode 168. Have you ever encountered strange behavior when trying something new in Python? What are common quirks hiding within the language? This week on the show, Christopher Trudeau is here, bringing another batch of PyCoder's weekly articles and projects. We discuss a recent blog post that lists a collection of quirky Python behaviors. We share a few examples with explanations, but leave several as puzzles to dig into. Christopher transitions our discussion into Python features that can be difficult to explain to a new programmer. We also share some of our stumbling blocks while learning the language. We cover several other articles and projects from the Python community, including a couple news updates, previewing Python 3.12's more intuitive and consistent f-strings, finding performance bottlenecks with profiling, emulating a 6502 processor in Python, using Rich to inspect Python objects, and plotting statistical data with Let's Plot. This episode is sponsored by Porkbun, the best domain name registrar to get your .xyz domain. The future of the internet is the .xyz domain. Get yours for around $2 now at porkbun.com/xyz23. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there.
Excited to dig in this week. We have just a couple pieces of news, and we're both going to take one of these each. So what was your news item?
Yeah, it's funny. Off air, we were discussing the fact that some of the stuff we call news when we only chat every 2 weeks, and then it takes us a bit to get an episode out. And so the title of news is a little funny, but here's some news.
Yeah.
The one that's going around around the web a lot right now, especially on sites that have a tendency to rename themselves. The official announcement from the Python Steering Committee that PEP 703 has been accepted.
Yeah.
In case you don't all have the PEP numbers memorized, 703 is better known as the no-GIL PEP. Yep, you heard it here, probably not first.
Yeah.
The GIL is being removed. So in order to try and minimize any backward compatibility challenges, 2.7, the removal process is going to be as follows. First, both a GIL and no-GIL build will be available simultaneously. They're hoping this will begin in Python 3.13, which would be October 2024.
Okay.
The library maintainers will then have time to build binaries that match the new signature. But of course, that will mean supporting both versions for a while. The hope is around the 5-year mark, the no-GIL version will be the only choice. There was a bunch of language in the announcement leaving wiggle room on the dates, recognizing that as the work progresses and more information becomes available, things could change.
Yeah.
This is kind of a big deal and not at the same time. So if it's done right, a significant percentage of Python coders will never see any difference at all, maybe some performance improvement. For library maintainers, especially those who write extensions, this is going to be a little extra work for a couple years. But the goal is to do what is actually a massive change under the hood using as seamless a process as possible. I believe you've got a little news as well.
Yep. This is about polars, which we've talked about on the show, and it's come up in lots of data science discussions of late. And I don't normally go on Reddit, but I did recently, and on the r/Python Reddit, there was an announcement, and it was from Richie Vink, who's the creator of polars. They were announcing this, that they're starting a company and that it will be built around polars. And it's kind of cool because it is almost exactly 3 years ago that he made the post in the same subreddit announcing the polars project to begin with. So kind of a neat transition in 3 years. But I definitely have seen the popularity in the data science world and people that are working with large amounts of data. There's a lot of excitement around polars, and also there's a lot of excitement around this kind of stuff. We talked about Will McGugan creating his textual company, and I think that's great. I approve of these types of companies compared to lots of other sort of VC things I see. So good on them. So what's your first topic this week?
Well, can you believe it's been almost 10 episodes since I've uttered the name Leodonis Pozoromos?
Oh, no.
Wow. So we're overdue. My first article is by our most prolific author, and it's called Python 3.12 Preview, More Intuitive and Consistent F-Strings. As the 3.12 release approaches, you're going to see more and more content like this, highlighting those features that are coming. A bunch of work in 3.12 goes to make the F-string format a little more consistent and a little more sane. This is yet another one of those things that can be done because of the switch over to the PEG parser back in Python 3.9. So we're still gaining language features from that change, which is kind of neat. F-strings were introduced in 3.6 as a replacement or addition to the old C-style string format, as well as the .format call. And oddly enough, though, they were never actually part of the official Python grammar. They had their own syntax, and a custom parser was built into CPython for dealing with these kinds of strings. So it was kind of a separate beast. The changes in 3.12 make F-strings actually part of the grammar, and underneath, that means the core developers have less work, as they no longer need to maintain two parsers. And it also means for other implementers like PyPy, they can just implement the grammar. It's all part of the spec now, which is nice. And so for those of us just using the language, it also means some things that couldn't be done before now can be, but most of it's under the hood. The older parser had a couple limitations. For example, there were limits on how escaping worked, meaning you could run into challenges when you had to nest quotes in quotes. There were ways around this, but they were, ways around it. So, it's cleaner now. The first thing that they changed was how quotes are handled inside of the braces in an F string. So they're no longer considered part of the string, which means you can use the same kind of quote on the outside of your string as on the inside of the brace, say to access a dictionary key. They're enabling this, but then they're immediately turning around and saying, linters should probably tell you this is a bad idea. So just because you can.
You might suggest a different style.
Yeah. So I'm not sure how I feel about this one. And I know it's going to be a mess. It's going to mess up a bunch of syntax highlighters until everybody catches up. So, yay. Along the similar lines, you can now use a backslash inside of an F string brace. So this allows you to do things like perform a join on /n inside the braces. So far, I'm indifferent. Both of these were things that didn't happen all that often, and I could equally argue that it'd be clearer if you just don't do it. But that's a style opinion thing, so, whatever. The next one, though, is something that I kind of like, which is comments. So this is useful inside of multi-line strings, where you can now put a comment inside of a brace. So if you've got some chunky, big multi-line code going on, you can remind yourself why you did that right in the middle, which is kind of nice. So ever since the PEG parser was introduced, there's been an initiative to sort of improve error messages from the compiler. And by moving the F-strings into the grammar, the code for parsing the F-strings can now take advantage of this error handling as well. So now the parser is going to be able to better point out where in an F-string the problem is, rather than the old code, which basically said, hey, invalid syntax, and then you got to figure it out yourself. So the rest of the article covers some of the limitations that still exist in F-strings, like what to do with lambdas and how to escape braces and things like that. Definitely looking forward to 3.12. And if you want some good examples of some of the things I've been talking about, the article is a great preview.
Yeah, my topic that's coming up digs a little bit into a feature for Python 3.12 also. So there's a lot going on there. And man, Real Python, we've been hitting it often with lots of little sort of articles in the pre-release zone to give you an idea instead of like just announcing it all at once it comes out. Lots of previewing that you can do on the site right now. Python professionals use the .xyz domain. It's the ideal domain extension for AI-powered solutions, blockchain, and Web3 uses. Since every domain name at Porkbun comes with tons of freebies like SSL certificates, Whois privacy, DNS, URL forwarding, and hosting trials, you'll have everything you need to launch a professional, high-performance .xyz site with a few clicks. Because we pay for things that should be free, right? Intelligent solutions require limitless possibilities. Unlock yours with a .xyz domain. Now available for only around $2 at porkbun.com/XYZ23. Okay, so my first one is titled Profiling in Python. The subtitle is How to Find Performance Bottlenecks. This is a real Python tutorial by Bartosz Jaczynski, who we've mentioned several times on the show before. And it takes you through several tools that come with Python and a couple third-party tools that can help you profile your software. So one of the big questions would be like, well, is that necessary? And that really depends on your code, I guess. If you're a beginner, I don't think profiling is something you're going to run into right away. Even an intermediate developer, it may depend on how often that code runs versus the trade-off of like, okay, well, if I optimize the code, is it going to take longer than the code running and things like that? So if you're wanting to answer some of those questions of like whether optimizing is even necessary, or maybe drilling into what parts of the code you should focus on, this is a really good tutorial to kind of dig you into it. And I think it can be a really good teaching tool, hence why it's interesting to me and why I like bringing up this kind of stuff on the show. There's a bit of a programming note here. After the tutorial came out, the creator of another very powerful profiling tool contacted Bartosz and sent him an email telling him about, hey, if you're going to write about profilers in the future, you might want to check this out. And Bartosz connected him with me, and we just recorded a show this week. And the conversation was with Emery Berger, who is from UMass Amherst. He has created a tool called Scalene, and he and his students have been working on that tool and updating it. And that conversation will come out in a few weeks. And it was really fun. And so if you're interested in profilers or maybe even kind of more advanced kind of things in profiling, that conversation digs really deep into that stuff. Going back to this tutorial, Bartosz provides a short checklist to figure out where you want to work on performance and whether this is a good choice. So the first step would be, hey, have you tested your code to prove that it's actually working as expected and without errors? And then maybe as you look at your code, does your code need some cleanup, and could it potentially become more maintainable or more Pythonic, as we like to say? Making sure the design of it is done well. Then maybe the third step would be, okay, let's identify inefficient parts of your code by doing something like profiling. And the tutorial follows into a set of tools. One of the set of tools, or one of the types of tools, I guess we could call it, is a timer. And there's a tool called Time and another one called Timeit that are standard library modules. In fact, there's another third-party tool made by one of our friends here, Gera Nahiela. It's called Code Timing. And I'll link to an article that actually describes the whole process of him coming up with this tool that you can use to go through a variety of ways of timing your code and looking at it. And it's a nice tool if you're looking at something just to see how long things take to run and a variety of ways that you could implement timing your code. Bartosz dives into two other types of profilers. One is a deterministic profiler. That's like something called profile or C profile. And then there's also ones that do line profiling. And then kind of a contrast to that is something called a statistical profiler. He shows off one called PyInstrument and another one called Linux Perf Profiler, which is, again, what I was mentioning, hinting to before. The 3.12 release is offering this as part of a feature. If you are running Linux, you can run this Perf Profiler. From there, it kind of digs into each one of these. He measures the time execution. Each one of these has code samples with it where you can run this and try this out yourself. He then goes from time into Timeit, and you can do much more benchmarking there with short code snippets. And it can be Timeit's a neat tool if you've ever seen it before, that you can set up parameters for it to run multiple times and give you this better averaging, and it avoids some of the problems where are you timing like importing your code as opposed to the code running and things like that. And this helps kind of give you an idea of that. From those time type of things, he digs into the deterministic profiler of cprofile, and it collects really detailed runtime statistics. It's kind of a go-to for many developers. It falls into that deterministic camp, and it'll show you what functions were called and how many times they were called, and kind of where the time was spent in your program. But depending on the way your code is written, this may not tell you a whole lot. The answer could be, wow, spent a lot of time in main. And it's like, okay, well, if that's the only primary function that's happening there, it may not give you a whole lot of help. So if you divide your code up into multiple functions, then it could show you potentially within these separate function calls where this performance is headed and what's happening. One kind of problematic thing that I definitely got into in my other conversation about performance is that it does take some overhead because the code is running kind of in parallel with it, and it can produce a lot of noise in its reporting. And so there's kind of this trade-off a little bit. And depending on the tool that you have, it can be like 50% slower or even more than that when you run something like cprofile, because it's sort of standing on top of things and monitoring all these things in the background. That's where we lead into the other type of profiler that he covers, which is the statistical profiler. And the one he's using in this case is called PyInstrument. It's a third-party tool. And this takes snapshots of what's happening in the call stack. And it really doesn't affect the overall performance because it's kind of sitting on the side and just sort of sampling what's happening as it's running. The overhead is much more, I don't know, uniform. It's not going to be running into the same kind of bottlenecks potentially by doing that kind of deterministic thing. You can, I guess, adjust your sampling rate, which is kind of unique. This particular tool is a little limited in the sense that it doesn't report on code that runs in multiple threads or calls that go into something like a C extension module, which again, that depends on the type of programs you write. But we talk about that very often on the show about, ways to speed up processing is by digging into those other layers and using calls to extension modules and things like that. So this is another side note. The one that I'm going to talk about later, that upcoming tool actually really shines in that area. It does that. It profiles memory. It shows where code runs, not only on the functional level, but at the line level. It monitors for memory leaks and a whole bunch of other really interesting stuff, and has a very small hit to performance, which is kind of impressive. So after kind of digging deep into PyInstrument, he then goes into Perf. Again, this is the Linux Perf profiler. And I almost would turn it over to a separate article that he wrote as another preview that digs really deep into this. And he actually talks about setting it up. And, one trick to this is that you do need to be running Linux and specific hardware for it to be able to do this sort of profiling. But it really provides detailed information about the entire stack. It can go into hardware events, system calls, library code, and really much, much more. And kind of funny, previous guest, Pablo Galindo Salgado, he is the designer here. He's been very, very involved in doing not only the releases of 3.10 and 3.11, but also here in 3.12, he's been working a lot on contributing to this feature. He came on the show to talk about Memray back in episode 128, which is another profiler, again, kind of digging deep into this idea of profiling your code, and this, in this case, memory and where it's being used and spent. So this is even a much more detailed one that is, again, going into like hardware events and system calls and other things beyond just memory. But he explains a lot of the benefits in there, and there's links to that other tutorial. So this tutorial is really thorough. It gives you code examples, like I said, to try out and run each one of these things. It includes a new format for Real Python. There's a section at the end called Key Takeaways, which is kind of this interesting thing where like there's a question that's in sort of a collapsed portion of text there that you can sort of think to yourself and test your reading comprehensions and of the concepts covered, and then sort of expanding it. I'll give you an example of one. The question is, what's software profiling? And the answer is, profiling a program is about measuring and analyzing its numerous runtime statistics in order to find hotspots or performance bottlenecks. High memory consumption, inefficient CPU use, and excessive function calls can be common indicators of potential issues in your software that need improvement. So just kind of giving you detailed answers on the types of things that were covered throughout this particular article. So key takeaways is going to be kind of a feature that we're adding to a handful of our tutorials and articles kind of heading forward. Yeah, I enjoyed it. It's a interesting dive into profiling and helped me turn into yet another episode by Emery Berger reaching out to me. So we're going to cover his tool called Scalene in an upcoming show. Do you run profilers yourself? And if so, which ones are you running, Christopher?
I haven't had to do it in a while. With the vast majority of the work I do is on the web.
Yeah.
Usually the bottleneck tends to be the database.
Okay.
Or
IO of some kind.
It doesn't tend to be the computation of the thing you're actually doing on the back end. So it
makes sense.
It's a diminishing sort of return there. Years and years ago, when I did more work on embedded systems, where every clock cycle is important, I tended to use that kind of tool for those situations. But I haven't had to do very much of it in Python.
Okay. So you're digging into a very interesting topic next.
Speaking of embedded, I didn't even do that on purpose. So my next one's from a site called Daily Stuff, which is kind of a hybrid site. It's got some blog posts, some sort of tutorial training stuff, and then it's just recently added a project section. The project section gives you details on how to build something. There's no bylines on the project section. There are in the blogs and stuff, so I can't give credit to whoever wrote this. It's just Daily Stuff's content. And the title is called Writing a 6502 Emulator in Python. So the 6502 is a CPU from Motorola based on its 6000 series. It was used in the original Nintendo Entertainment System, in the Sega Genesis, and in the Commodore 64. So for you youngins out there, this was the computers the dinosaurs used.
Yeah.
So there's no real need to build an emulator, except that it's kind of fun to build an emulator. And it's an interesting way to sort of learn about how the actual CPUs work and what's going on underneath inside of the computer. And it's kind of favorable to do an older one if you're going to play in this space, because they've got fewer features. So you can understand the basics of what's going on before you get bogged down in complexities of a more modern CPU. 6502 is an 8-bit processor. Yeah, that's right, 8 bits, back when you could count your bits on your hands. And it used 16-bit values to store things in memory. So in order to emulate it, you're going to need to emulate the memory storage, as well as how the instructions on the CPU worked. To make things more interesting, there are 2 kinds of instructions that deal with memory in this architecture: immediate and indirect. An immediate instruction takes an address as an argument, and the indirect kind uses the contents stored at an address as its address. So yeah, memory pointers right down at the assembly level. So fun. So the first chunk of the project instructs you on how to build an object in Python that represents the memory in the system. The memory is divided into regions. The first chunk is used to store special variables and constants. And in the real machine, that was built especially for speed. So, a locality is not quite a cache, but kind of similar to that idea. The second chunk is the execution stack, where your function call mechanisms live. And then the last chunk is general memory, where your programs and their data are stored. So the Python object you build has to deal with this, and it uses arrays of bytes and then implements dunder getItem and dunder setItem methods to mimic addressing a chunk of memory using square brackets. With the memory built, the next challenge is then, of course, the processor. And the article goes on to walk you through the idea of a register, which is where a CPU stores things, a program counter, stack pointers, status flags, all this great stuff. And you have to build all of that in Python to get your emulator to work. To help out along the way, it shows you how to write unit tests for it. So you're running code that runs the emulator's code, and you can check that it's working. And so there's an amazing amount of depth here. So if you're looking for a project to play with, or you just want to learn a little more about how a CPU works, it's an interesting read.
Yeah, it's very, very detailed when they get into these sort of tables that are at the end.
Yes,
of
all the opcodes and yeah.
So my next one is, I don't even want to call it an article. It's hardly a blog post in some ways. It's called Python Quirks. It's from Nathan on the site writing.piercy Net. So I don't know if his last name is Piercy or not, but it's a newsletter and you can subscribe to it. There's some other interesting writings on that. But as I said, it's not much of an article or really much of a written piece. It has a single headline, my ... favorite ... Python oddities. And if you aren't aware, there are, well, you probably are aware, but if you're listening to the show, but if you're not and you're a beginner in Python, there are some odd and strange, quirky things that Python does, which could potentially bite you depending on if you've heard of it or understand what's going on. And many of these things, Real Python as a website has been designed to cover a lot of them. And, you may come across in many of our written tutorials and articles and things like that. And others, you kind of have to do something interesting on many of them to get these odd things to happen. I'm going to provide a couple of these. They're all kind of written out in codes with just like a headline. The first one is about generators. The next one's about references, and then about assignment and so forth. I'm not going to dig into all of them because I really feel like this is a great set of puzzles that if you are not familiar with these things, that you can kind of sit and sort of think about, well, why is it doing that? Why is Python behaving in this interesting way? I'll highlight a couple. And then he also, as kind of an additional piece at the end, has a bunch of links that go into other resources where other people are writing about this, and there is bigger, fuller explanations, but there aren't in this particular example. It's rather stark the way it's presented. One of the oddest ones that, if you're looking at it and maybe coming from a different language, is, let's see, what is it identified as? Exponentation, if I can pronounce it, but how exponents work kind of in Python. A common way of writing raise something to the power of is to use that sort of rooftop looking caret symbol. So 2 raised to 3. And as you type that into a Python REPL, that would output 1. And it's because the operator in Python isn't the caret for raising to the power of. It actually is 2 asterisk symbols, the thing that you use for multiplication. So if you wanted to raise 2 to the 3rd power, or cube 2, you would do 2 star star 3. So what is this sort of operator doing? It's a bitwise operator. It's in fact the bitwise OR operator in Python. So it's doing a completely different type of thing. And so that could bite you, again, if you're not familiar with it, and definitely looks odd to a lot of people when you see it kind of appear there. One that has always been a favorite trick of many people that I know teaching Python or showing Python stupid tricks up on something like Twitter or whatever, is this tuple behavior. And it's actually kind of a cool thing that you can actually swap values in a single line of code. If you have 2 values, A and B, and let's say you've already assigned them, you can write out to swap the 2 of them. You can do it in a single line. You can put A, comma B, and then use the assignment operator of equals and B, comma A. And that will swap the values between the 2 of them. There's no need for intermediate values or places to hold things or whatever. And the reason is the way that tuple assignment and works inside of Python. It's able to address that directly, which is really kind of cool. And the last one I'm going to mention that is neat, that's inside of here, well, neat in the sense that you need to be aware of it, is a problem with default arguments. If you have a function that has a default argument and it's mutable, like in the case of a list. So let's say you define foo and it has a value of A equals empty list. Well, A is now a mutable object. It's a list that you can keep updating and changing. And if you, in the body of the function, have it say a.append, say another value, X or something like that, and you print it out, the first time you run that program, you're like, oh, great, I'm going to get an empty list and it's going to append a single item into it. Yeah, but the next time you run it, that value from the last time you ran it is still there, and you're now appending a second value to it. So it's kind of surprising to a lot of people, but it has to do with the fact that it's mutable, and it's also kind of the fact that it, even though the scope is only within that particular function, it's still addressable, and it's kind of a problem. And so I'll include a link to one of our articles about it. It's better that if you're going to try to do that and you want to have a list variable inside of a function like this, it's better to define it to something like none initially and then create the thing after it. Anyway, there's a couple of things that are in that same kind of mutable camp as far as like how Python deals with references that are kind of included here. But so those are my couple. I don't know if you had some yourself, Chris, that you liked out of this list.
Yeah, that mutable one is it's a massive foot gun. I have shot off a few of my own toes with it in the past. Yeah, it's one I tend to try to, you kind of have to show to students once you start teaching them functions. So, some of the other things that are in there that are quirky, it's sort of like, you're never going to do this.
Right.
And it doesn't quite make sense why it does it that way, but that's fine, whatever. If you're interested in the mechanics of the is operator, you can learn why 256 is and 257 isn't because of the way things are cached. But programmers, you shouldn't be using the is operator, so it doesn't matter in this situation, right? So that kind of stuff I don't find bothers me as much. Yeah, the default mutable is a big problematic one that you definitely need to learn early on in your Python career.
Yeah, something else that we talked about is this inheritance thing, and it kind of goes back to the metaprogramming stuff that we've talked about a few times. The way, again, I feel like it's such a cliche, but it's so true that everything in Python is an object. And so if you start using this tool of is instance and you say, okay, is instance, and you're looking at like an integer or something like that, is an int a type, and so forth. And as you start doing more is instance, and you get down to like is instance type comma an object, true. And then what's odd is the next line is instance object comma type. Yeah, that's true too. So it's some interesting things that kind of are happening in those down low levels of defining what objects and types are inside of Python. But yeah, it's an interesting list. There's a whole bunch of ones. And then, like I said, it's probably more fun for me to leave a lot of these for you to kind of puzzle through. I mean, if you need help, there are some links at the bottom to kind of dig through. But it's just, again, not so much a tutorial or article in this sense, but just sort of, an interesting list of quirks. This week, I want to shine a spotlight on another Real Python video course. It showcases a data visualization library with a similar approach to one of the projects mentioned this week. The course is titled Graph Your Data with Python and ggplot, and it's based on a Real Python tutorial by Miguel Garcia. And in the video lessons, previous guest and core team member Martin Royce shows you how to install the library Plot9 and set up Jupyter Notebooks. You'll use Plot9 to create visualizations in an efficient and consistent way. And you'll combine the different elements of the grammar of graphics, which involve several layers, including a data layer, aesthetics layer, and a geometrics layer, along with additional techniques within the grammar of graphics. You'll learn how to perform statistical transformations and how to implement a visual style with themes. And finally, you'll learn how to export your data visualization to files. Data visualization is a crucial step towards sharing your results and findings, and I think this course will be a worthy investment of your time. Real Python video courses are broken into easily consumable sections, and where needed include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com.
And it leads us very, very nicely, nice little segue into our discussion this week, which is a fellow Python educator, Trey Hunter, recently posted on Twitter or whatever they're calling themselves this week. I got to get over that. I'm getting bitter. What Python feature would you have trouble explaining to a new programmer? And in fact, my answer to him was that initialization problem with malleable function signatures, because it is that foot gun that I was sort of talking about.
Yeah, it's such a surprise when it happens. So
yeah. The discussion was kind of interesting. You get a lot of the sort of regular things that pop up.
Yep.
A guy named Brent O'Connor replied with an exhaustive list, which was basically like that's it, we're done. We don't have to have any more conversation. It was decorators, list comprehensions, context managers, magic methods, multiple inheritance, differences between a tuple and list, and virtual environments. I'm like, okay, there's your list.
Here you go.
So, yeah.
Yeah, I've said multiple times on the show that when I joined Real Python and started looking at things that I wanted to teach, many of them were the things that I looked at the language and said, that is odd looking. I want to learn what that does. And decorators was the first one. And it took me quite a while to kind of get through it. But yeah, the idea that again, objects and so forth, but functions are objects too. And you can actually put a function inside of a function and have it return a function, and all that kind of stuff is a little mind bendy, especially to a beginner who's maybe just run scripts up to this point. And as you see those @ symbols, you're like, what is that? What's going on there? So that it definitely requires a bit of a course to kind of sit down and have somebody write it out for you.
And at risk of getting overly pedantic about a simple tweet and its responses, I did find like part of what I found interesting about the conversation was, I don't know whether people were just ignoring the word new in the question, or whether their expectations for a new programmer are completely different to mine. Because something like the decorators to me are interesting, right? Because they're messy to implement, but you don't really need to understand them at a basic level to, if I go and wrap a class method with the, if I want to create a class method by wrapping it with the @class method decorator, I can tell a student, look, this is the magic word that you put on top of it to turn it into a class method.
Right.
We don't have to talk about the spell. The spell can be 5 years from now, when you're in the potions class, right? So I did find that kind of interesting, right? Like somebody said, meta classes. And I'm like, I'm not having that conversation with somebody who's like...
new is going to be way far away from that.
I'm not having that conversation with an experienced person, let alone with the new ones, right?
Yeah.
And it's similar, sort of like async, await, that kind of stuff. And it kind of, and of course it always does, but as soon as you get into these kinds of conversations, somebody turns it into a packaging conversation.
Yeah, right away. Yeah.
And to me, that's kind of the same thing, right? Like, yes, the packaging ecosystem is a mess, but I can explain to you why you need a virtual environment in a minute.
Yep.
And I can show you the 3 commands you need to install stuff, and you never have to think about it again.
Yeah.
If you're going to go start writing packages, yes, that's a much deeper thing. But again, I don't put that in the bucket of new programmer myself. But
yeah. And if people are going to share their code, it's going to be more likely they'll share the entire script, and across a network or something like that, as opposed to having to install it up. And I agree on that. Virtual environments were one for like a new programmer that is like a unique concept. I was able to grok it pretty quickly, even though I was new to Python, but I kept having to explain it multiple times to people I worked with. I think it's just like, unless they actually experience, creating one and sitting there with it and understanding what it's setting up for them, it takes a minute. I disagree on one of them, the one about installing. That is our fight from a couple weeks ago. I feel like, python.org, it's really not that hard. There are lots of other ways that are out there, but that one is pretty consistent and can be pretty simple if people want to look at it that way.
I was just going to say that I do wonder with the virtual environments whether it's partially an age thing, because we used to have to deal with like DLL hell, which was the same problem, right? Like it was, you install this program installed that DLL, that program installed that DLL, and it would cause the first one to fail, right?
Yeah.
So it's possible that you and I, being old men, having seen this issue outside of the language, it just sort of goes, okay, yeah, I see you're having that problem, and this is how this language has solved that problem. So, so that could be a been there, done that kind of thing.
Yeah, somebody put typing on there. Again, as a new programmer, it was more in the context of me looking at code that was written and me seeing something that was, this is a crude way to say it, but not functional. Like it wasn't doing something that I could see right away what it was doing with the code. I'm like, why is that stuff there? Why is this extra definition happening? I'd seen other static languages and the way that they define the type, in front of it. And this was doing this defining after it. I was like, it was just weird. And so that took a minute. And so I did a course on that. And so that helped me kind of wrap my head around it. But yeah, I mean, there are a handful of these things in there, but other one I saw in there was the name main idiom. That was another one that when I first saw it, I was like, that's interesting. Why are we doing it this way? And we have a course coming out pretty soon that covers that. And I think actually might be kind of handy for some people that, just want to see like, why is it being used and how, what's kind of going on there. So
that one to me is like really, really fixable. All they need to do is add a built-in into the language that is the same thing as that check as a Boolean and name it something reasonable. And it no longer has to be this magic thing that you're putting on the bottom and explaining, right? It's
right.
Call it whatever. Is main, is runnable, is something, and then all of a sudden it would just be, it's essentially solving the exact same thing in something that would be far more readable rather than having to explain dunders.
Yeah.
And in fact, that was one of the ones we've been talking about recently because I'm working on an object-oriented coding course at the moment. Whether or not dunder init is a constructor. And I really don't like that argument, but I do find
yeah.
the idea of dunder init is in and of itself is interesting because I understand why it's a system special call, and it on one level, from a CS level, it makes sense.
Yeah.
From a teaching it to a new person, it's like, okay, why this is this weird thing, right? Like, it
looks odd too. Again.
And other languages, they name the constructor the same thing as the class, or they name it constructor or something that just feels a little more intuitive.
Yeah.
But it's that old adage, right? Naming things is hard, and unfortunately, you're stuck with the decisions that were made, 25, 30 years ago. And here you are.
Exactly. So. Yeah. So it's kind of a short thread, but there are some interesting ones in there, and. Sorry if our link to it doesn't work. That's not our fault. But if you do have a Twitter account, you should be able to access it and look at it. But I think we hit most of the ones that were in that list. So, well, cool. I think that takes us into projects. I think you have one based on a name that I mentioned earlier. Also, lots of connectivity here this week.
Yes, yeah, we seem to be doing this. My project this week is sort of a project and sort of not a project. It's an article from Will McCougan, the textual guy, and he writes about the Rich library. Rich has been covered before. In fact, Will's been on the show. And what made this particular article show up on my radar, though, was it's a non-rich way of using rich. So built into the library is a function called inspect. And this takes an object and spits out a bunch of information about it. And because it's in rich, the output is formatted very nicely for your terminal.
Yeah.
So with inspect, you can see all the attributes on the object along with their current values. With an extra argument to inspect, you can also see all of an object's methods. The method info even includes the method's docstring, available in either a summarized or a full detailed mode. So you've got control as to how much it spits out. So it's just like if you're in the REPL and you're wanting to look at something, it is a nice, clean output of a whole bunch of information, a sort of a replacement for vars or dir kind of thing that you might do, but looks a lot better and gives you more info. So it's a nice little tool to add to your debugging library. And there was even a little addendum at the end of the article that they added afterwards. Somebody added the information about how you could automatically stick this in your namespace.
Yeah.
So that if you're, in your REPL, you don't have to import it, that it can always just sort of be there. So it was, always good stuff from the folks at Textual, and another little debugging tool to help you out.
Yeah, that default set of methods for like your REPL was something we covered recently too. Recently being a couple months or so. I think it was on Lay It On, another one of his articles or whatever about modifying the REPL. Yeah, I agree that it's one of the prettiest ways to look at that information that I've seen. So my project is from JetBrains. JetBrains creators of a variety of different tools. Probably PyCharm is the one most people have heard of, but they make a variety of tools for data science work and things like that. And they have made an open source plotting library for statistical data. It's kind of cutely called Let's Plot. The Let's Plot API is largely based upon an API provided by a tool from the R language called ggplot. And ggplot was one of the first libraries, if you ever done R, that it's the go-to tool there. And it's based on a kind of a interesting thing called the grammar of graphics. And there's a whole book that dives into this. And the grammar of graphics requires sort of three things as you kind of look into it. The first is the data, which is the information where you're going to create the plot, and then aesthetics, which provides the sort of the mapping between data variables and the aesthetic or graphical variables used to sort of define that sort of underlying drawing system. And then it has geomes or geometric objects, which define the type of geometric object you're use in the drawing. And you can use points, lines, bars, and lots of other things. RealPython has a video course, and it probably will be the course spotlight this week that digs into another tool that's in a similar way covering this stuff. It was called Plot9, which is another kind of wrapper and look at this whole idea, digging into the ggplot and the grammar of graphic stuff. So I'll probably link that this week. But the library is really nice. It has really good documentation, includes a whole Jupyter Notebook sort of cookbook kind of tool. The output's very, very pretty. I like the interactivity of it. It has probably some of the better looking tooltips and the customizability as you hover your mouse over things and seeing what the data is doing and giving you even more detailed information than just seeing the overall map. So there's a whole section of the documentation that digs into charts, contours, marginal plots, visualization of errors, smoothing, bivariate distribution, time series, images, facets, coordinate system, blah, blah, blah. It goes really, really detailed into it. But then it has a whole other one about maps and proportional symbol maps, choropleths, a whole bunch of other kind of layer things that you can then apply using that sort of ggplot2 style. Even gets into geocoding. It's a neat library. It really digs into a lot of stuff, and I'm a big fan of visualization and looking forward to playing with this a little bit more. There is a unique technique called sampling, which you can use to address large data sets that you can kind of tend into over plotting things. And so you can kind of reduce the amount of things that are being plotted out by applying sort of sampling techniques to it, which is neat. It works really well in Jupyter Notebooks, or I guess they have a tool called Datalore that it works very well in also. So yeah, let's plot. Thanks again, Christopher, bringing all these articles and PyCoder's goodness this week.
Glad to be here.
All right, talk to you soon.
Cheers.
And don't forget, embrace the future of technology with a .xyz domain name. Go to porkbun.com/xyz23 to get your .xyz domain name now for just around $2. I want to thank Christopher Trudeau for coming on the show again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.